this is what a register diagrammatically looks like. So you can just draw it as one block. You can denote the number of bits it holds. You can show the individual bits. You can divide it into the lower segment, higher segment, and so on. So generally registers in a computer are either 32-bit or 64-bit, and 8 bits make 1 byte. So basically one register can hold either 4 bytes or 8 bytes. Most of our present day computers are 8 bytes, but those are the two commonly used sizes, but there are other sizes as well. So that's just general information about a register. And these what we'll be looking at in the next few slides on and off are some syntax, some notations of the register transfer language, how certain ideas are expressed in RTL. So when you transfer the contents of R1 to R2, R1, R2 are registers here. This is how you represent them. This is an arrow, and this indicates simultaneous transfer of all bits from source to destination, meaning if R1 is a 4-byte register and R2 is a 4-byte register, all the 32 bits from here are transferred to here at once. That is parallel representation denoted by this arrow. Conditional transfer is the same thing happens, but if a certain condition holds true. So if the variable p is equal to 1, then this parallel transfer will happen. If the variable p is equal to 0, then it will not happen. So this is the RTL equivalent of your if x is true, then y equals z. If x is false, do nothing. You have the code you write equivalent to that in RTL is represented this way. And this is the hardware representation. So you have a control circuit here, which is basically any combinational circuit which gives you one output p value. The p is again a binary variable which can take either 0 or a 1. So if it takes 1, then this transfer will happen. If it takes a 0, this transfer will not happen. That is conditional transfer or control transfer. These again are more symbols. So parenthesis denotes a part of a register. So like I said, you can have a register with 32 bits. So if you want to convey an instruction which involves only the first 8 bits, then you can use R2 of 0 to 7 or R2 of lower segment and so on. Arrow we just saw is the transfer of information. Colon denotes the conditional or the control function. So if p, then do this, otherwise don't, that one. Comma separates two micro instructions. So when you are writing a series of instructions, to separate them you use the comma. And capital letters are used to denote a register. So when it's the MAR, MDR, PCIR, general purpose registers, they are generally denoted by capital letters. So all these, like I said, are just notations or syntax. So when you are learning a programming language, you learn that printf is used to give the outputs, scanf is used to give the inputs, and you learn keywords like that, right? So these are the register transfer language equivalent of those keywords.